From the earlier sections, we've been talking about the polar form for a complex number, and then in section 8.5, we're going to start to truly introducing the polar coordinate system. So for polar coordinate systems, it's actually made with two things. The first one is called the r, the radius, and then the second one is the angle theta. And the polar coordinate is very similar to a unit circle. It actually only made with a pole, which is the starting point, and then a polar axis. And when we try to find the location for any point, normally we will give you the measure for the radius for the r, and then the measure for the angle theta, either in the degree form or the radians form. And for example, I'm talking about some angle theta with some random radius r, then my location is going to be this point. So this is going to be the location for some random r comma theta, with the distance is r, and then the angle is theta. For example, I have 3 points I want to plotting them. The first one is point P, has radius of 4, and then the angle is 135. The second one is Q, has radius of -3, and then the angle is pi over 6. And then the last one is R, with a radius of 2 and the angle -pi over 2. So I'm going to use different colors to graph them on the polar graph here, polar axis here. So the first one, P, says the radius is 4. So I'm going to labeling each one of them as unit 1. So 4 units. So that means my point is going to be along in this circle with angle 135. You can see on the side they will label the angles. So angle 135 is going to be here. So P is going to be 3, 4, and 135. So that's the angle, the point P. Okay, so for the second one, we're talking about Q, has radius is -3, and then the angle is pi over 6. Let's find the angle first, because we cannot talking about a negative angle for right now. So let's talking about the angle pi over 6 first. Pi over 6 is here on the polar axis. And then we know 3, that means I'm just going to 1, 2, 3. However, since this is a -3, along the pi over 6, we're going to go to the other direction by 3 units. So 1, 2, 3. So this is the Q point. So in other words, Q, -3 comma pi over 6 is the same point as 3 comma 7 pi over 6. 3, 7 pi over 6. So you can thinking about that. I'm talking about the angle pi over 6, regardless my radius. It is possible my point is along this pi over 6 line, either going to the positive side or negative side. That will depending on the angle, the sign for the radius r. Okay, then the last one, we have radius r equal to 2, and then the angle is negative pi over 2. So as we talking about the angle before, going counterclockwise is positive angle, going clockwise is negative angle. So 2, negative pi over 2, we can thinking about is negative pi over 2 with positive 2. So this point. However, it's also the same point if we do not want to using the negative. It's also the same point 2, 3 pi over 2, or any other possible locations. For example, negative 2 pi over 2. So pi over 2 is here, but it's negative, so it's going to the going away from the pi over 2. Okay, so that means for any point I have on the polar coordinates, it is possible for me to have multiple different way to representing the same location. Before we end this video, I'm going to do one more example. We're actually going to combining 8.1 along with the 8.5. So here, I want to convert a polar coordinate, which is P, 2, 30 degree. Remember, 2 is your radius and 30 is your angle theta. We want to convert it into rectangular form. And then in section 8.1, we're talking about the following formulas. X is going to equal to r cosine of theta. Y is going to equal to r sine of theta. And then we also have r squared equal to x squared plus y squared, or r equal to square root of x squared plus y squared. And then tangent of theta equals to y over x. Here for this problem, since we're going to convert it to the rectangular form, we're looking for x and y. So we're going to use the top 3 formulas to find x and y. So x is going to be r cosine of theta, where r is 2, theta is 30 degree. So cosine of 30 degree is square root 3 over 2. So x will equal to square root 3. And y is r sine of theta, which is 2 sine of 30 degree, which is 2 times 1/2, and we got 1. So the rectangular form is going to be square root 3, which is x, and then 1 is y.